Hi everyone, and welcome to MathSux. This video is going to help you pass the Geometry Common Core Regents. We're doing this one question at a time. Here's question 1. In right triangle LMN below, LN is 8, MN is 15, and LM is 17. If triangle LMN is translated such that it maps onto triangle XYZ, which statement is always true? So notice they don't even show us triangle XYZ. What we really need to know is what values stay the same after a translation. So when we translate a shape, we're just moving it from one point to another. So let's just draw out what XYZ might look like. So if we were just to draw out XYZ, that means we translated the shape, let's say like over 2 units to the right. So if we're doing LMN, so L is here, so that means X. So each point is going to coordinate to another. So L is going to become X, M is going to become Y, so M is over here, so that means Y is going to be over here. N is going to become Z, so N will be the last point over here, Z. And then since we just translated it, it just means we moved it over. So that means everything else is going to come with it. So all these side links and this right angle are going to come over as well. So now we could see that the lengths are going to remain the same and the angles are going to remain the same. And then we could just go through each answer choice and see which makes sense. So choice number 1, xy is equal to 15. So xy we could see is equal to 17. So that's not our answer. Yz is 17. No, it's 15. Angle z is 90 degrees. Yes. So angle n became angle z, and both of these are 90 degrees. And if you look at the last one, it says angle x is 90 degrees, which is wrong. So our choice here is choice number 3. Question number 2. Directed line segment KC has endpoints k, -4, -2, c, 1, 8. Point E divides KC such that KE to EC is 3 to 2. What are the coordinates of point E? So this is, when you see these kinds of questions with a proportion and it's asking, there's a formula that we're going to need to do 2 times, one for the x value and one for the y value. So let me just write out that formula. So we'll do it for the x values first. So where do we get this information from? This is a formula you have to memorize, but now to fill this in, I'm just going to label our points and our ratio into these values. So this k will be x1, y1, this c will be x2, y2, and then 3 to 2, this will be a to b. So now we're just going to plug in the numbers that they give us. So x1 we said is -4, plus a is 3 over a plus b, so we're just adding 3 plus 2, times x2, we said it is 1, minus x1, which is 4. So minus -4 will give us plus 4. And if you plug this in your calculator, so this will give us -1. So x is equal to -1. So right away we could see that choice number 1 is going to be our answer, because this is these represent coordinate points. But just to be sure, let's also find this y coordinate. So let's do the same thing using the same formula, but now using y. So instead of x1, we're going to do y1 plus a over a plus b times y2 minus y1. And then we're just going to use the same values we've been using up here. So this is going to be equal to y1, which is -2, plus a, which is 3, over a plus b, 3 plus 2, times y2, which is 8, minus y1, which is -2, so that's actually going to become a plus 2. And then we could plug this in our calculator, or it's going to give us 4. So y is equal to 4. So then we get this coordinate point of -1, 4, where x is -1 and y is 4, which is choice number 1. Question number 3. In right triangle Dan, angle A is 90 degrees. Which statement must always be true? So let's first draw out this triangle. We have a right triangle where angle A is 90 degrees, and then D or N we could put on either side, and it's not going to affect our answer the way we draw it. So now let's just go through one at a time and see which of these makes sense. So if we look at number 1, saying cosine of d is equal to cosine of n. So just a reminder of what all these trig functions are. We have SOHCAHTOA. So cosine of d, so we're looking over here. So we're looking at cosine, so cosine of d is the adjacent dA. So the adjacent to this angle d. So over here, that's going to be dA over the hypotenuse, which is dn. And we're saying that's going to be equal to cosine of n. So now we're looking in relation to this angle n. So if we look at angle n, we see the adjacent now is an over the hypotenuse, which is dn. So you can see these are not equal to each other. So let's try the second one. Cosine of d is equal to sine of n. So now we're going to go back to d over here. So we just found that cosine of d, so we know it's dA over dn. And we're seeing that's equal to sine of n. So now we're going to look at sine of n over here. So here's n, and this time we're getting the opposite over the hypotenuse. So the opposite to angle n is going to be side dA. And then over the hypotenuse, which is dn. And you could see that these are equal to each other. So this is going to be our answer. Question number 4. In the diagram below, a parallelogram RSTV, diagonals SV and RT intersect at E. Which statement is always true? So this question is going to be based on knowing your parallelogram properties. So let's go through each of these and see what makes sense. So the first one says SR over here, this side length, is going to be congruent to RV. So just by looking at this, we can see that that doesn't make any sense, right? In a parallelogram, that's not always true, where consecutive sides are congruent to each other. So this is not the answer. This would be true if this was a rhombus, though. Choice number 2, RT is congruent to SV. They're saying the diagonals are congruent here. So again, no, that's not a property of the parallelogram. Choice number 3, SE is congruent to TE. So notice that doesn't look right. That's half of this diagonal and then this part of this diagonal. Not a property of a parallelogram. And then by process of elimination, we know it's going to be choice number 4, but let's look at what it is. RE over here is going to be congruent to TE. So yes, parallelograms diagonals do bisect each other. So that means that this is going to be congruent to this, and the same thing would go for SE to EV. And I'm just going to write the property on the side. So there's a bunch of different properties to remember with parallelograms, so please be aware of those. There's a lot of memorization for these kinds of questions. Question number 5. In triangle SNA below, UE is parallel to NA. So line UE is parallel to line A. If SU is 3, SN is 11. So just filling this in as we go. And EA is 13. What is the length of SE? So we're looking for this value over here, to the nearest tenth. When we have these parallel lines, what we're really saying is that this ends up forming congruent angle relationships. So this angle U will be congruent to angle N. And this is just based on corresponding angles when two parallel lines are cut by a transversal. And then this angle E will be congruent to angle A. And then this angle S is going to be equal unto itself. And so when I say it's going to be equal unto itself, what's really happening here is that there's two triangles that form with this line. So we have the bigger triangle, S and A, and we're saying it's similar to this smaller triangle, SUE. So these two triangles are similar by angle. So I'm just going to write that. Triangle SUE is similar to triangle SNA by angle. And we found that because of all these angle relationships. We know S is equal onto itself, and then we have N and U, and A is congruent to angle E. Because they're similar to each other, we can create a proportion and then find this missing value, SE. So I'm just going to continue with the models we have here on the side and fill in the length. So we know that SN, the whole length here, is 11. Here SA is going to be x plus 13. And now let's look at the smaller triangle. We have SU is 3, and then SE is x. And now we could just set up a proportion. So we have this left length here is 11, and we're going to put it kind of 11 over 3. And then we could set it equal to this length over here, x plus 13, over x. And then we could just do some cross multiplication. So if we just do this, we get 11x is equal to 3 times x plus 13, and then just solve this as normal. And we get x is equal to 4.9. And if you look back, just to make sure we see that's what we were trying to find. We were trying to find this value SE, which we set equal to x, which we now know is 4.9. So the answer is choice number 3, 4.9. Question number 6. Many roofs are slanted to prevent the buildup of snow. As modeled below, the length of a roof is 5.5 meters and it rises to a height of 2.5 meters. The angle of elevation of the roof to the nearest degree is what? So we have a right triangle here, and we're trying to find the angle of elevation. So the angle of elevation is going to be this angle right here. Okay, so let's write out, this is going to be a trigonometry problem, so we're going to be using SOHCAHTOA. So if everything is in relation to this angle, if we look what values we have, so we're trying to find the value of this angle. So if we look at what values we have in relation to this, we have the opposite value, and then we have the hypotenuse. So if we look at what trig function has the opposite and hypotenuse value, we see we're going to be using sine. So we're going to have sine of theta is equal to the opposite, 2.5, over the hypotenuse, 5.5. And to get this in our calculator, what you're going to do is you're going to plug in sine, arc sine. So we're going to go to second sine, and then we're just going to plug in this fraction we got, 2.5 over 5.5. And we get this number, 27.03569. Okay. So now if you look back, it says the nearest degree. You want it rounded, so this is going to be 27 degrees, which is choice number 3. Question number 7. In the diagram below, CT is parallel to AR. So we know these are parallel. We know that's going to create different angle relationships. ACE, so this line here, and RC are drawn such that AC is congruent to RC. So this is going to be, so this right here is like a little isosceles triangle right here. If angle ECT is 75 degrees, let's fill that in, 75 degrees. What is angle ACR? ACR. So we're trying to find this value here. Okay, so this we know angle T is a line, and so we know that this whole thing is going to have to add to 180, right? So let's do 180. So to get this value, we're just going to do 180 minus 75, which is going to be equal to 105. So this over here is 105 degrees. So because of this vertical line, we also know that this in here would be 75 degrees. So imagine this kept going, and this would look like our typical transversal, where these are corresponding angles. So if this is 75 degrees, this is 75 degrees, and we know this is an isosceles triangle, then this angle is also going to be 75 degrees. So what we're going to do is 180 minus 75 to find the value of this last angle here. It's just 180 minus 75 plus 75, which will give us 30 degrees. Question 8. In the diagram below, triangle ABC has medians AX, BY, and CZ that intersect at point P. If AB equals 26, so this whole thing is equal to 26. So since they're medians, that means like each of these from Z to B is going to be half of that. So Z to B is going to be 13, and then A to Z will be 13. And we could just do this all the way around. Next it says AC is 28, so this entire thing is 28. And then we know AY is going to be half of that, which is 14, and then YC is going to be 14. And lastly, it says PC is 16. So PC is not this third side, but it's right here. PC is over here, which is 16. What is the perimeter of triangle CZA? So now it's asking for the perimeter value of CZA. So we're trying to find the perimeter of this triangle. So if we take that out, let's just get a clearer picture of it. It looks something like this. So we see that one side has a value of 13. This big side has a value of 28. And then we know, so here's point P. We know up to this point, this value is 16, but we still don't know this value right here. And that's gonna be the tricky part to this question for finding the perimeter. The thing about medians of a triangle is that it has its own theorem, the median of triangle theorem. So it intersects at a point known as the centroid, which is point P, which is 2/3 of the distance from the vertex to the opposite side. Let's say this entire value is the value of x, and then it gets split up, where this is like 1/3 of x, and then this is 2/3 of x. So based on this theorem, we know that 2/3 of x is going to give us 16. So we don't know what the whole is, but we know that 2/3 of whatever the whole length is going to give us 16. We'll divide 2/3 on both sides, and we'll get x is equal to 24. So before you circle the answer, notice it's not even a choice in here, which is good. Remember that this value 24 is the whole length of this thing. Remember, what they're asking for is actually the perimeter. So what we're going to want to do is add up all these values now. So we want to add up the length of 24 that we just got, right? We're finding the perimeter of this triangle CZA. So we have this new length 24, we have 13 that they gave to us earlier, and then we have 28. So when we add these all together, we get 65, which is choice number 2. Question number 9. In right triangle ABC, angle C is equal to 90 degrees, AC equals 12, and angle A is 25. Which equation is correct for triangle ABC? So clearly we're working with this angle right here, 25 degrees, and we're given the adjacent. And it looks like we're dealing with tan down here. So I'm just going to write out SOHCAHTOA. So when we have tan, if you look at the answer choices, we're dealing with tan. So we have the adjacent, and we're also dealing with the opposite A. So we're trying to find A. So we have the opposite over here. Let's just label everything, opposite and adjacent. So if we have tan of 25 degrees, and we're looking for A, it's going to be equal to A over the adjacent, which is 12. Now to find A, all we would do here is cross multiply. So we would just, instead of dividing by 12, we'd now multiply 12 on both sides. So that cancels out on the right, and it's left over here 12 times tan of 25 degrees is equal to A, which is choice number 2. Question number 10. Triangle HUS is shown below. If point G is located on US and HG is drawn, so let's say G is over here in the middle, and we have this line here. So we have point G located on US and HG is drawn, so we did that. Which additional information is sufficient to prove triangle HUG is congruent to triangle HSG? So that's why I drew this in the middle, because we're trying to prove these two triangles congruent by side angle side. So we don't have enough information to do that, and that's where these answer choices come in. But if you were just to look at side angle side, what that might look like, you would probably choose this as a reflexive length HG. They would share this right angle over here, and then another side, depending on the information they give us, will prove that GS is congruent to UG. So we have the side angle side. This is assuming that this line ACE-G is a perpendicular bisector to side SU. So that's what we're going to be looking for when we look at this. So if we look at the choice number 1, that says HG bisects US. So the reason this isn't the answer is because if HG bisects US, that tells us that UG is congruent to GS, and we get this other side reflexive property HG. So we'd only get the sides, but it doesn't say anything about angles. So that's why this is not enough information. If we look at HG as an altitude, so HG is an altitude, that would give us these two angles. UGH is congruent to SGH, and we would still have this side, the reflexive property, but we still don't have the other sides. We don't know that these are being this is being bisected, and that these lengths are equal. So also not our answer. HG bisects angle UHS. So that would be good for an angle up here and this side, but we're still missing another side, so that's not the answer. And then the last one, HG is a perpendicular bisector of US. So this is going to be our answer, but we kind of already mapped out why if this is a perpendicular bisector, that means it's going to go from H to G, and then it's going to form two right angles that will be congruent. This side will be equal, and then the perpendicular bisector will cut this length in half, US, so UG would be congruent to GS. So that's our answer. Question number 11. The area of the base of a cone is 9 pi square inches. Let's first draw out this cone. So it says the area of the base of the cone. So this is talking about the area of just the base of the cone. So just the base. So that just means the circle. So the base of the cone is the circle. So the area of the circle of the base, which is the base of this cone, is equal to 9 pi square inches. The volume of the cone is 36 pi cubic inches. So then the volume of the whole cone is equal to 36 pi cubic inches. What is the height of the cone in inches? So we're trying to find this h value here. So just a reminder of what the area of a circle is. It's pi r squared. So knowing that, we could set this equal pi r squared equal to 9 pi, and then we could just find the value of the radius, taking the square root of both sides, and we'll get 3 is equal to r. So we know that the radius here is 3. And using that, we can now find the height of this cone by using the volume formula. So the volume of the cone formula. So the volume of the cone formula is equal to pi r squared h over 3, which we know is equal to 36 pi because they told us that in the answer. So now we could just use algebra to figure out what h is, which is what they want to know. We also found what the value of the radius is, which we know is 3. So this is going to be 3 squared times h over 3 is equal to 36 pi. And we'll just do some algebra to figure this out. Okay. And we get the height is equal to 12, which is choice number 1. Question number 12. On the set of axes below, A, B, C, D, E, F, G, H, and I, J are drawn. Which segment is the image of AB after a dilation with a scale factor of 2 centered at -2, -1? So first I'm going to look at AB. So let's find it on here. We have AB is over here. Notice that the dilation that we're going to do is centered at this point -2, -1. So let's first find -2, -1. 2, down 1, it's over here. So everything we're going to be doing with this dilation is going to be in reference to this point here. So that means we're going to find the coordinate of A in relation to this point. So we're going to kind of treat this like it's a new origin. So we're going to ignore the usual 0, 0 origin, and this is going to be like our new origin. So I'm going to draw a little temporary axis here. And now we're gonna count the x and y units as if this is our origin. So if we find A, we're gonna go find x first. So we're going to the left, 1, 2. So we know -2, and then up 1, 2, 3, 4. So A in relation to this point is -2, 4. Now let's find B. So we're going to the right for x, 1, 2, 3, 4. And then up 1, 2. And now we're going to do that dilation. So remember, we're multiplying each coordinate point by 2 when we're doing a dilation. So we're always multiplying for dilations. So in this case, we're going to just multiply the x and y values by 2. So this new point is going to become -4 to 8. And then we're going to do the same thing down here. This will become 8, 4. So now if we look back up here, remember we're still working with in relation to this new coordinate plane we just made. We're going to look for these new points. So if we go 1, 2, 3, 4, and then up 8, 1, 2, 3, 4, 5, 6, 7, 8. Notice this aligns with point E. Now let's do the same thing with B prime that we got. So let's go over to the right 8, and then up 4, and that aligns perfectly with F. So this answer that we're getting is line EF. So this question worked out nicely with the multiple choice, but if this were a free answer, you would want to convert these points back to like the real origin, where the origin is at point 0, 0. So if they wanted to know what the coordinates were, they would want the coordinates in relation to the origin. So if we were to do that, we would just be finding the coordinates of E and F in relation to this, to our usual normal origin. So if you did that, it would look something like this. And then for point E, same thing. And these would be your final answers. But that's our answer. I also have a video that goes over a bunch of different examples and goes more into how to do questions like this, so please check that out. Question 13. Trapezoid ABCD is graphed on the set of axes below. Which transformation would map point A, so we're looking over here, onto A prime 3, -7. So first let's look at what point A is. So our original point A is, let's see the value, 1, 2, 3, 4, 5, 6, 7, -7, and then 3. And we're saying A prime becomes 3, -7. So if you just look at these coordinates, you could see that we just swapped them. -7, 3 became 3, -7. So if you happen to remember the rule for that, it is a reflection over the line y equals x. So we know this is going to be choice 1. But let's map this out and see why this makes sense. So the new point is 3, -7. So here's 3. So let's find this new point. So this is the new point. A prime is 3, -7. And over here, this was -7, 3, A prime. So now we could see if we were right, if we were to look at these answer choices, the reflection over the y equals x is the only one that makes sense. So if you drew, so this is a line y equals x, it just goes diagonally straight through the coordinate plane. And if you counted the number of units from each point to the line y equals x, you would see that they were equal. So let's just do that experiment here. So this is 5 units. You kind of count diagonally, right? 5 units to the center. And then here let's see if we get the same thing. So this also is 5 units to this center line, y equals x. So that's our answer. Question 14. A storage building is modeled below by a hemisphere on top of a cylinder. So notice this is like a sphere, but it's like a half of one, so it's a hemisphere, and we're on top of the cylinder. The diameter of both the cylinder and hemisphere is 12 feet. The total height of the storage building is 30 feet. To the nearest cubic foot, what is the volume of the storage building? So we want to find the volume of this whole thing. So we're going to need to split this up into the hemisphere and the cylinder. So So let's first focus on this hemisphere. We're going to notice here is that this whole thing is 30 feet. But if we're just focusing and finding the volume of the hemisphere, we're going to need to break up this height and find what the value of the radius is. So how do we do that? So what's great about this is that down here is also the diameter, which will give us the radius. So 12 feet is the base of the cylinder. It's also going to be the top part of the cylinder, which shows us that the radius is going to be half of this, which is just 6. So we know that the height here is going to be 6, leaving the rest of this height for the cylinder to be 24. So now we can go ahead and find the volume of this hemisphere. So the volume of a hemisphere is going to be equal to 4/3 pi r cubed. But don't forget, we're going to be dividing this whole thing by 2, or multiplying it times a half, because it's half of a sphere. So this is the volume of a sphere in here, and then we're going to multiply it times a half because we're just doing half of it. So when we do this, we're going to plug in all our numbers, which we just needed the radius, which now we know is 6. And we could just plug this in on our calculator. And we get this number 452.3893421. Okay, so this is just the volume of this over here, but we also need the volume of the cylinder itself. So the volume of the cylinder, the formula for that is pi r squared h. So we have pi r squared h. So we plug this in. So we're going to have pi times r, we know is 6 squared, times the height. So remember, we split this up, so this is going to be 24 for just the cylinder. Plug that in. And we get this long number, 2714.336053. I'm holding off rounding because with rounding things can always get a little funky, so I never want to round until the end just to be safe. So now we're going to take these two numbers and add them together, and that will be the total volume of this entire shape. Add that all together and you're going to get about 3167, which is choice number 3. Question 15. Which regular polygon will carry onto itself after a 135-degree rotation about its center? So this question, we're going to have to draw some shapes and picture what they're talking about. So for the first choice, triangle. So I'm going to assume this is an equilateral triangle. So an equilateral triangle, so we know that each, let me draw this bigger on the right. So for number 1, we have a triangle. So we're going to assume that that's an equilateral triangle where each angle measure is going to be 60 degrees. So if each measure is 60 degrees, for this to rotate correctly, 135 would have to be divisible by 60 degrees. So we're just going to take 135 degrees divided by 60. So we're wondering how many turns the triangle will go onto itself. Is that even possible? So 135 divided by 60. So because this number is a decimal, we know that this is not going to rotate onto itself in 135 degrees. Now if it was 60 degrees, we know it would turn and it would go onto itself, or 120 degrees, it would take that would be 2 turns and it would go onto itself. But 135 degrees, this does not go onto itself. So let's look at the next one, a pentagon. Pentagon has 5 sides. An evenly spaced pentagon would be 360 divided by 5 because there's 5 sides. So that means each angle measure would have 72 degrees. And now we're going to do the same thing where we divide 135 degrees divided by 72. And we get something that's not a clean whole number. So this is not going to be our answer. Now let's look at a hexagon. A hexagon has 6 sides. So let's see what the angle measure of each of those 6 sides is going to be. Right, okay, so we have 6 sides, so 360 divided by 6 is 60. So we actually already checked 60 degrees, so we know that this isn't going to be an answer. By process of elimination, choice number 4 is going to be our answer, but let's look at why. Let's look at an octagon, which has 8 sides. It's like a stop sign. So the angle measure in this shape, 360 divided by 8 is going to be 45 degrees all around. So all these are 45 degrees. And now let's see 135 divided by 45 degrees. And you'll see that this is a whole number. So we know that it would take 3 turns of rotation of an octagon, a regular octagon, to go onto itself. That would be 3 turns. And choice number 4 is our answer. Question 16. What is the length of the radius of the circle whose equation is x squared plus y squared minus 2x plus 4y minus 5? So here we're going to be completing the square, which has a lot of steps and could be hard to remember and follow sometimes. So the first thing I'm going to want to do here is just get all the x's near each other and all the y's near each other. So we have an x squared and a minus 2x. Then we have a y squared and a plus 4y. And then this minus 5, I'm just going to bring it to the other side over here, and it's going to become a plus 5. Okay, so now we're going to be completing the square 2 times, once with x and once with y. So let's start with x squared minus, so this is 2x. So I'm going to take this number and I'm going to divide it by 2. We're always going to be dividing this second number by 2. And then I'm going to get negative 1. And then I'm going to square this number, which gives us 1. And I'm going to take this number and put it in here. So that is a lot of steps. But we're always dividing by 2, squaring it, and then we end up putting it in this box here. And we'll see why in a bit. And then we're going to do the same thing with y. So we have y squared plus 4y, and then we're going to do the same steps where we divide by 2. 4 divided by 2, we get 2. And we're going to square it. We get 4. And then we're going to just kind of, I'm putting it in this box for a reason. So this is going to be equal to 5. And then all the numbers we boxed off here that we kind of just found, we're going to add them to the other side. So 5 plus 1 and plus 4. So anything we did to one side, we're going to do the other side. So since we added these numbers here, we want to add them here also. So now we're going to rewrite this into a different format. So we're going to take x, and then the number we found here is actually the number we're going to use. So this is going to become x minus 1 squared. And then we're going to do the same thing with y. So y, and then we're going to take this number we found here, plus 2 squared. So this might all seem very random, but if we took this out, x minus 1 times x minus 1, and we distributed this, we would get x squared minus 2x plus 1. And that's why we end up completing the square. I'll show you quickly. Which is what we wrote here, x squared minus 2x plus 1. So that's why we rewrite the equation like this, even though the steps seem kind of random. So let's go back over here. So we want to add these numbers on the right together. 5 plus 1 plus 4 will just give us 10. And this actually gives us all the information we need. It gives us the center and the radius. But if you look at the answer, they're just looking for the radius. And the radius is always going to be this number, but the square root of this number. So r is equal to radical 10. And if it asks you for the center, that would be 1 comma negative 2. But they just wanted the radius for this question. So this is choice number 2. Question 17. The line represented by the equation y equals 4x plus 15 is dilated by a scale factor of 2 centered at the origin. Which equation represents its image? So this time we're dilating an entire line with a scale factor of 2. The thing about this is dilating a line, you only want to use a scale factor for the y-intercept, which is b, which in this case is 15, right? So this is the b, this is m, the m, the slope, this is b, the y-intercept. So if we're dilating by a scale factor of 2, we're just going to multiply this 15 times 2. So we get 4x plus 15 times 2, which gives us 30. Which is choice number 2. So I'm just going to make a little note about that on the side here. Question 18. Line segment RH has endpoints R, -4, 4, and H, 2, -4. Which equation represents a line perpendicular to RH that passes through the point 3, -1? So first let's find the slope for this line segment. So we're dealing with this point R, -4, 4, and then H2, -4, and we want to find a line in point slope form, so we're going to need the slope and the y-intercept. So first let's find the slope of this. So remember, the slope is just going to be the rise over run, y2 minus y1 over x2 minus x1. So let's just label this x and y, and then we'll make sure we go in order. So I'm going to go, it doesn't matter which way you go, but I'm going to go this way. So this will be like our y2. So we have -4 minus the other y coordinate, which is 4, all over 2 minus -4, which is going to be +4. So -4 minus 4 is -8 over 2 plus 4 is 6. And then we can reduce this to -4/3. So our slope is -4/3. So now we want to know which equation represents a line perpendicular to RH. So whenever we see perpendicular, we know that we're going to be doing the negative reciprocal of the slope. So we found the slope of this line, and we actually want to make a line that's perpendicular to that line and passes through a certain point. We're going to take the negative reciprocal of this. What that means is we're going to flip and negate. So we're going to take 3 and we're going to put it on top, 4, put it on the bottom, and then see this negative, it was a -4/3, now it's going to be positive. So we're going to have +3/4. So we have our slope, and then they give us our point. So we actually don't have to find our y-intercept. They give us our point, and it's in point slope form, so we actually don't need to find the y-intercept. So our point that they give us for this line is 3, -1. And then we just have to put this in point slope form. So just a reminder about what point slope form is. It's y minus y1 is equal to slope m times x minus x1. So here y minus -1 would be y plus 1 times our slope, the negative reciprocal of -4/3, which is 3/4, times x minus x1, which is 3. So we get this in point slope form, y plus 1 is equal to 3/4 times x minus 3, which is choice number 1. Question 19. In right triangle SNO below, altitude NW is drawn to hypotenuse SO. Which statement is not always true? So because we're drawing an altitude from NW to SO, this is going to form a right angle on both sides. They're asking which statement is not always true. So of course, when we have these kinds of questions where we have a triangle and an altitude drawn, it's going to end up forming 3 similar triangles. So I'm just going to sketch those out. So first we have this big triangle that's easy to see, triangle SNO. So let's draw that out separately over here on the right. And then notice they have these other triangles, triangle SWN and triangle WNO. And just to keep everything consistent, I'm going to want to draw them the same way so the right angle is in the same place. So also be careful, we want to make sure the sides are also in proportion. So when we're drawing these other triangles, we want the right angle in the corner, but we also want to keep the shorter side vertical and the longer side as the base. So notice this triangle looks like it could be triangle WNS, where W is at the right angle. Its shorter side, it goes WS, and then the longer side, the hypotenuse, will be SN. And now our last triangle here. The right angle is at W, shorter length is to N, and then the longer is to O. Okay, so now we can look at these, and remember we're trying to find things that are not always true. So if we look at SO, so let's find SO in our triangles. We have an SO over here, over SN, so we have the hypotenuse over this shorter length is equal to SN. So here we have an SN, another hypotenuse, so SO is equal to SN over SW. And then here you could see this is going to be in proportion because we have SO to SN, hypotenuse to hypotenuse, and then we have SN to SW, this side length to this side length, which is also in proportion. So that because this does make sense, this is not going to be our answer because we're looking for something that's not always true. So now let's look at the next one, SW. So here's an SW over NS. So we're doing that proportion again we just did in the previously. So we have SW side, short side length over the hypotenuse, NS is equal to NS over OW. So NS is over here, but OW is down here on a completely different triangle. So already this is looking like this is going to be our answer. But let's go through the others and make sure that they make sense because this one doesn't. This is incorporating all three triangles, which doesn't make any sense. Next one we have SO over ON. So we have hypotenuse over the base is equal to ON hypotenuse over OW, the base. So hypotenuse to the base, hypotenuse to the base. So this makes sense. So that's not going to be our answer. And our last choice, OW, let's see if this makes sense. OW over NW, so base to vertical side length, and then to NW to SW. So these are also in proportion. We have the base OW is equal to NW, base to base, and then NW side length, SW to other side length. So this makes sense and is not our answer. So our choice here is choice number 2, that incorporates all three triangles and doesn't make any sense here. Question number 20. A rectangle has a width of 3 and a length of 4. So let's just draw that out. So a rectangle has a width of 3 and a length of 4. The rectangle is dilated by a scale factor of 1.8. So let's draw this out. Let's see what this will look like once it's dilated. And when we're dilating, we're just multiplying. So we want to take this side length and multiply it times 1.8. And when you do that, you're going to get 7.2. The width, 3 times 1.8, we're going to do the same thing. 3 times 1.8, we're going to get 5.4. And then let's look at what it's asking for. It's saying, what is the area of its image to the nearest tenth? So now we just need to find the area, which we know we're going to multiply length times width, which will just be these two side lengths times each other. 7.2 times 5.4, and we're going to get 38.88, which will give us 38.9, because they asked us to round it to the nearest tenth and get 38.9, which is choice number 4. Yeah, so for dilation questions, don't just multiply the scale factor of 1.8 times the area of the original shape. Make sure to do it step by step and dilate the side lengths first and then find the area. Otherwise it's not going to work out right. Question 21. In the diagram below of circle P, diameter MD, so here's our diameter MD, and chord AL intersect at Q. Angle AQD is 46 degrees, and arc LD over here is 124 degrees. What is arc AD? So we're trying to find arc AD, this value right here. And notice this looks like we can use the angles of intersecting chords theorem, because we have this diameter and then we have this chord. So here we could just use a formula where the vertical angle is going to be equal to 1/2 of the intersecting chords. So the intersecting chords is AD, so half of arc AD, plus the intersecting arc on the other side, which is ML, so arc ML. So if we plug our numbers in, what we have, so our vertical angle is just going to be this, 46 degrees, is equal to half of arc AD, which we don't know yet, that's what we're trying to find. And then notice we don't have the value for ML either, but what we do have is information to find it. We know that this is the diameter, line MD, and we have LD, which is 124 degrees. So the thing about diameters is they cut the circle in half, so this whole thing, MD altogether, should be 180 degrees. So if we already have we already know this is 124, we're just going to find ML by subtracting 124 from 180. Because this whole thing has to add up to 180. And we get 56 degrees over here. So now we can plug in the value for arc ML, which is 56 degrees. And we could just do some algebra. So we want to distribute here. We get 46 is equal to 1/2 arc AD plus half of 56 is 28. Arc AD is equal to 36 degrees, which is choice number 1. Question 22. The right prism with the triangular base shown below is cut by a plane perpendicular to its base. So be careful here. So this perpendicular to its base. So our base of this shape would be the triangle, but we want to cut a plane that's perpendicular to it. Perpendicular meaning it makes like a right angle with it. So we're going to be kind of slicing a plane down. So if we slice a plane down this way, notice we would get a rectangle. We're kind of like asking what shape is over here on the end that is opposite to its base, and it would be choice number 4, a rectangle. Question 23. A rectangular fish tank measures 24 inches long, 12 inches wide, and 16 inches high as modeled in the diagram below. If the empty tank weighs 25 pounds and the fish tank is filled with water to a height of 14 inches, what is the approximate weight of the tank and water? So there's a couple of things here that could be a little bit tricky because you think we're going to want to find the volume of the numbers that we see in front of us on this tank that they already labeled, 16, 24, and 12. But notice that we're just filling this tank with water up to a height of 14 inches. So really, we're kind of not filling it up all the way to the top, we're just filling it up to here. Really, we're going to be using the height of 14 inches when finding the volume. So the whole thing is 16 inches, but we're filling it up with water up to 14 inches. So the volume with water of this prism is going to be 14 times 12 times 24. And those numbers multiplied together is going to give us 4032 inches cubed. Another thing it's saying is what is the approximate weight of the tank and water? This little conversion over here, because they want to know the weight, they don't want to know the volume. So it gives us this conversion of 1 pound of water is equal to 27.7 inches cubed. So we're going to take this number, the volume, 4032 inches cubed, and then divide it by 27.7 inches cubed. And this will give us the number of pounds, which is what we're looking for, the weight. So when we do this, 4032 divided by 27.7, we get 145.5595668. So before we circle choice number 1, 146, be careful again, there's one more thing here. What is the approximate weight of the tank and water? So this is what we just found is the weight of the water, but we don't want to forget about the tank, which they mention over here weighs 25 pounds. So we're going to be adding 25 pounds to this value we just found. So this plus 25 is equal to 170.5595668. So there's a lot of different components in this question that could be tricky. And when this is rounded, you'll see that we get 171, which is choice number 3. So definitely a tricky question. Question 24. A circle has a radius of 4.5. So let me just draw that out. What is the measure of the central angle that intercepts an arc whose length is 6.2? So basically we're having an arc that we're going to create with 2 radii. So we have 4.5 over here, 4.5 over here, and this creates a central angle, right? And we want to know what that central angle is. They also give us that the intercepted arc is 6.2. So this over here, this arc has a value of 6.2. We want to know what the value of this central angle is here to the nearest degree. So this question, again, is a little tricky. It involves proportions. So let's set up a proportion. So we know what a proportion looks like. Something like this. We're going to be finding this value that we don't know, x degrees out of the whole, which is 360 degrees, right? Because there are 360 degrees in a circle. And now the next thing we can do here is use this arc information that we have. We have this length here of 6.2, and then in relation to the whole length around the whole circle, we can just use the circumference formula to find that. So circumference formula is just pi times diameter, and we know what the value of the radius is, so we can find this value. So this is going to end up being 9 pi, right? Because to get the value of the diameter, you just add 4.5 plus 4.5, which will give us 9. So we have 9 pi, so that's going to go on the bottom here. So I'm just going to label everything where each part of this came from. This is partial circumference, whole circumference, partial degrees, and then all degrees of a circle. So we have the degrees and the length around the circle, basically, when setting them equal to each other. And now we could just cross multiply and find the value of x. So this is going to give us 6.2 times 360 is equal to 9 pi x. And we could just use some algebra now to find this value. So be careful here when dividing by 9 pi. Make sure to put this value in parentheses, because otherwise you might get a different value. So don't take any chances. We do that and we get x is equal to 78.94, and they wanted it to the nearest degree, so we could just round this up to 79 degrees, which is choice number 4. So this is the end of part 1. Look out for part 2 coming out soon. I hope you found this helpful. Please let me know if you have any questions. Good luck and happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!